welcome to part 5 of this 5-part series sponsored by the Metal Building Manufacturers Association, MBMA, on fire resistance design for metal building systems. This final part of the series is on joints, their definition, the various types of joints that we will discuss. My name is Nestor Ivancu. I am Senior Engineer with Jensen Hughes, and for the last 10 years I have been the Fire Protection Code Consultant for MBMA. A brief disclaimer, users are cautioned and reminded that they should always be compliant with the local building code of record and the applicable standards and requirements. This particular presentation is based on 2009 IBC with some update information relative to 2015, but your local requirements may not be totally consistent with those. So always check what the actual requirements are. It is also assumed that the design professional is competent and is responsible for their own design decisions, and that final acceptance of any designs is subject to the approval of the local authority having jurisdiction. Part 5 is exclusively on fire resistance rated joint assemblies as well as continuity joints, and we will discuss at length the important distinction between those, so between a rated joint and just the ordinary, if you will, continuity joint. The previous parts of this series, part 3, was on columns and roof ceiling assemblies, fire resistance rated assemblies, sponsored by MBMA, and the preceding part 4 of this series was on fire resistance rated wall assemblies. Again, this is a 5-part series, and this is the final part of that series on joints. Here's an excerpt of a summary table of all of the MBMA-sponsored fire resistance rated assemblies. The website address for MBMA is given here. If we click on that, we will go to the website and we will see the complete table. So here is the MBMA website, and with in particular the fire protection part of it. If we scroll down, we will see this table in its entirety, and towards the bottom of the table we get to the subject matter of this presentation, which is the joints, and here's all of them. So there's basically 6 assemblies that MBMA has sponsored and developed over the last 5 years or so. Some are the fire resistance rated joints. These are your HW assemblies. The other ones are what's called continuity joint systems, and these are prefixed as CJ, so continuity joints. Brief description, view of what they consist of. They're all for 1 hour, and if we click on one of these, we'll be directed to the UL online database, and we can actually see the complete assembly as specified by UL. So here you can see the head of wall, the cross-section view, the 1 hour rating, the maximum joint width, etc., movement capabilities, and then the full listing with all of the components and items and installation requirements for the head of wall assembly itself. So here again we just summarize and highlight these 6 assemblies. So 3 of them are joints and 3 are wall continuity systems, and we'll describe what the difference is between them. So here's where your head of wall joint is in the building. It's the the void or the intersection between a vertical rated wall and a horizontal unrated roof. This is a typical construction condition encountered in metal building systems. You have a rated wall assembly either on the exterior of the building or within the building, and you have an unrated roof. And how do we install that joint, and what is the requirement? So there have been various interpretations as in the code and in terms of its enforcement over the years. A chronology of this is given on this slide with the very first IBC in the year 2000 through 2006. Only joints were defined in the code, and those were defined as intersections between two fire resistance rated assemblies. So both assemblies had to be fire resistance rated, and the joint in between them had to be fire resistance rated. So the question arose, since the typical metal building framing construction included rated walls meeting with unrated roofs, where does that joint fit in, and how is it to be treated? So that it really was a gray area, ambiguous in the code itself. There was a lot of discussion and confusion about what it really meant. And MBMA sought a code interpretation from the ICC and received one, and we'll talk about it. Following that, there was a numbering change in the 2009 IBC where the joints section changed their location, but that's just editorial for our purposes. The big change came about in 2012 IBC, where the code really made a explicit distinction between joints in between two rated assemblies, so sort of the traditional understanding and definition of fire resistive joints, and then what is the intersection between a rated and an unrated assembly, and how is that to be treated? The code faced that issue straight on and provided a requirement. And basically, 2015, no changes from 2012, and so far we don't see any changes forthcoming on that topic relative to the future, to the upcoming 2018 IBC. So let's go a little more slowly and in detail through these various points on this head of wall joint topic. So in the 2006 IBC, we had a section requirement on fire resistive rated joints, and these were defined as being in between two fire resistive rated assemblies, and the requirements were that these joints had to be tested and pre-qualified in accordance with either the ASTM E1966 or UL 2079 standards. So you had to have a fire resistive rated joint, a regular joint in between two fire resistive rated assemblies. The interpretation that we sought from the ICC was, how do we, or what is actually required when one has an intersection between a rated assembly and an unrated assembly? And the response was that the particular section 713.1 of the 2006 IBC is not applicable to such a condition, and all that is required at the intersection of a rated wall and an unrated roof are that the continuity of the wall, the interpretation letter said the continuity of the specific building element under consideration, but in this case it's the rated wall that was the subject, that continuity of that wall had to be maintained up to the other intersecting element. After this interpretation, and again as a result of all of the questions and the confusion in the industry on just what is needed, MBMA moved ahead to proactively test some joints, particular joints at underwriters' labs, to have at least something on the books that was tested and rated. The important change in 2012 was the new section 707.9, voids at intersections between a non-rated roof deck and a fire-rated wall must maintain continuity. And what that means, it must be securely filled with a material that will retard the passage of fire and hot gases. And it basically stops at that. What it doesn't say, but it's implied, is that these joints are not required to be rated joints. So as long as it's, as you have a secure infill of that void space, and that that material, that infill, will prevent the passage of fire and hot gases, that is adequate for providing continuity between a rated wall and an unrated roof. So that was first introduced in 2012, and that language continues in the code through now and into the foreseeable future. More recently, ASTM E2837, a new standard specifically on these situations of a rated wall intersection with an unrated roof, was issued, and it's specifically called wall continuity, head of wall joints. UL has been, since the issuance of the standard, UL has been testing new assemblies and issuing assemblies under that category of CJ listings. So there's a whole new set of assemblies for that specific application. In 2009, MBMA pursued developing an actual rated assembly at UL, and under the only available standard at that time, which was the fire resistance joint standard, which was UL 2079. Here is a photo of that assembly. It consists of the fire resistance rated wall at the bottom, just a typical 1-hour wall. Then we see where the joint part is the upper half of this. This is the cripple wall that attaches to the roof deck on top, and there's an overlapping sliding board section over here, and that's basically your joint. So your joint is basically right here, and it allows for a certain amount of movement of the roof relative to the wall as is required. Before the actual fire test is done, the test standard requires that there is movement cycling conducted on the test assembly. There's a certain number of cycles, and this movement goes up and down and basically tests the mechanics of the joint itself, the movement, that nothing hangs up or fails or damages the assembly in that process. All of that went smoothly. The only damage was some surface paper scratches, if you will, so no big deal. That same assembly then is put into the furnace. The 1-hour fire exposure is conducted, temperatures are measured, everything went well. And then to cap that off, the other test requirement is that the assembly has to survive a host stream test. And this test is important because it needs to demonstrate that the wall will still stay intact and provide a separation even during and after firefighters come in and fight the fire in the fire compartment. You still want to maintain that compartmentation. Our assembly satisfactorily passed that. and so the rating was developed for this system. Now again, at that time, the only test standard that UL could test to was the fire resistance joint standard. So the only listings, the assemblies that they could issue at that time were the head of wall assemblies, which are joints between two fire resistance rated assemblies. We had 3 configurations listed. We actually had 2 sets of tests, and they gave us the third assembly by engineering judgment and extrapolation. The 3 conditions were the joint directly under a purlin. Second one was perpendicular to a purlin, and then parallel in between purlins. So those are the 3 conceivable situations that one might encounter. All of these, again, because they had to be with fire resistance rated roofs, they referenced a protected roof. So the 3 P assemblies, P516, 265, and 268, all 1-hour assemblies. Now subsequent to that, after 2011, and I believe it was about 2013 or so, after the wall continuity standard was issued by ASTM, they grandfathered in a listing for the assembly that was actually tested, because what we had tested was did not have a protected roof. It was an unprotected assembly. So actually the cross-section on the right is the assembly that I showed you a photo of previously. And these are your CJD continuity joint listings that are currently in the UL directory and online. So you have the, remember where our red line was on the photograph? This is the red line here. So it's basically the overlapping board section between the upper part. The cripple wall that's attached to your roof deck is up here. You have your board and the overlap region, and then you have basically a telescoping part where the wall, the upper and the lower parts slide within each other up to a certain amount. Up here you can note that the fiberglass insulation is continuous over the purlin. It does not have to be interrupted and attached. The only thing is that it's basically compressed at the purlin, squeezed tight to connect the top track to the roof deck, and then it's sealed with fire caulk. For the test itself, we use the 3M fire caulk product. Since then, other fire caulk manufacturers have asked MBMA for permission and have obtained that, and they have counterpart assemblies basically identical to this configuration, but only using alternative fire caulk products to 3M. So there are some choices there. One does not always have to use 3M. I think there's 2 other manufacturers that have their products listed for exactly this type of an assembly. So aside from whether you're dealing, whether you have a rated to rated head of wall situation where you require a rated roof, or to the right you have a continuity joint system where you do not have a rated roof, the joint details are identical. One interpretation and application issue that we have had to issue some recommendations on as a result of inquiries to MBMA is potential use of these CJ joints, the continuity joints, which are rated for 1 hour, or for that matter the head of wall joints, which are also rated for 1 hour, if you have a 2-hour rated wall condition. Again, a reminder, and we brought this up before, that the IBC section 707.9 states that any gaps between a rated wall and an unrated roof must be securely filled to retard the passage of fire and hot gases. It is silent, does not say anything about a rating requirement or for how long that gap must be securely filled and retard the passage of fire and hot gases. So the interpretation is, and I think a valid one, that there is no rating time required. Given that, use of a 1-hour rated CJ or HW joint certainly, in our opinion, satisfies that requirement and exceeds that requirement because it has been demonstrated to actually perform its function for 1 hour. And the code is silent, as I said, on any time interval for how long that joint must remain secure. So that has been our interpretation and suggested application with 2-hour walls. There are some additional insulation issues prompted by the energy codes relative to this subject, and additional study and work will be forthcoming in the future on these details. That concludes part 5 of this series. Thank you for your attention.